Hi everyone, welcome back. And in this demo, we are going to learn how to create a binary tree. Now, there are two core concepts what we are going to use here. One is how to create a class so that we can store binary node data. Second concept is recursion so that we can traverse the tree. If you are familiar with these two concepts, it's okay. If not, we are going to cover both of these concepts. All right. So we are going to create a binary tree which will something look like this one where we have a root node and then L1 is the left node, R1 right node, and again L1 has a left node L2 and in the right side there is nothing, so we have given none for that, and it will look something like this. Okay, so now let's see like how we can create one particular node in Python, and then we'll connect it and create this full binary tree. If you see one particular node, it has three things. One, its own data, and the left node and right node. Let's create a Python class with these three attributes. Now let's create a class. I will call this class as binary tree. Now we need to define the init method. The init. And here we need three attributes. One is data, so self.data, and this data we need to pass while creating this object. So I will pass over here data, and this data will assign to self.data. Along with this, we'll have two more attribute. Those are left node, and value will be none because while creating a node will not have any left or right node. So similarly for right node, value will be none. Save this one. Now let's create an object of this class. I will call this object as root node, and value I will pass as parents. Okay, save this code. Now finally we're going to print this value. So root node dot data. Let's execute this code, and you can see we got the node value as parents. Now let's see how we can add a child node. So there could be two possible scenarios. One is when child node is empty, so that we are representing as none. And second case is when there is already one child node available. So these are two possible scenarios, right? In case if it is none, it will be very straightforward. We create a new node and we attach it with the root node. And after attachment, it will look something like this. Now for the second scenario, when we have already one child node, and over here I'm calling n1 child is already available, and then we created a new node n2, and we wanted to make n2 as a left node for this root. So first what we need to do is move this particular node over here, something like this, and then we'll move n2 over here as a left node for this root. Okay, now let's add a new method to add the left node. We'll call it add left node self, and we'll pass one data. This data will use to create the temporary node. So there are two possible scenarios. One is when this left node is empty. Let's see if self dot left node is none. In this case, we need to create a temporary node called temporary node, and We'll pass the data over here. Now we can simply assign this temporary node to left node equal to temp node. The first scenario is done. Now if there is already one child available, in that case we need to create the temporary node. After that we can move the node which is already available to this temporary node. Called temporary node left node equal to self dot left node, and finally we can assign left node to temporary node. Done. And let's test this code. So root node dot add left node, I will add grant daughter, and after that I will add daughter over here. Let's execute this code. Okay, in order to see this value we have to print this data over here. We'll call root node dot left node dot data. Let's re-execute and we can see we got parent and daughter. Now to add the right node we can use this method. We'll just copy and paste and we'll change value of left to right. This logic is same. Right, and over here it will be temporary, this will be this will be right, and over here will be right, finally assigning to right node. Done. Let's add root node, add right node to grant run, copy, paste here, and sum. If I wanted to see the value, we can root node dot right node dot data. Let's execute this code. And we got parent, daughter, and son. Now this is the last part of this video where we are going to discuss about traversing this binary tree. Now this is a perfect example for recursion. If you see right now I have 3 generation of data where we have parent, yeah, daughter and son, and granddaughter, grandson over here. Now there can be n number of generation we can represent using binary tree, and we don't know like where exactly we'll find the value, but we know for sure that if it is none, that means these are our boundary condition. We should not traverse once we see none. All right, now in order to traverse this tree I'm going to create a method outside. I will call it print all values. This will take a node as input, and let's print node value, and then we'll print node left node, print node right node. Let's call this method print all nodes. I'll pass root node here. Let's execute this code here. And we got the parent node, and this is a binary tree object. We wanted to see the value. What I will do is I will add a method here, the underscore str, and this will return value of this node equal to self.data, so that instead of getting this binary object address, we can see the value. And you can see we got the parent, we got daughter and son. Now let's make this function as a recursive, and for that you remember the boundary condition, that is if node is not none, then we should print its value, and we can call print all value for left node and print all value for right node. Copy this one and I will put it over here and here. So changes are done. A short version for this code, it will be remove this part, save this. So in case if there is something in the node, then we should print its value, then we should call print all value for left node and right node. Now let's execute this code. And you can see we got the value for parent and daughter, granddaughter, son and grandson. Now if I'll change this print statement and put it in between these, so now it will traverse to the leftmost node, then it will print its value, and for right node it will be as it is, same as the previous. So let's execute this code and see the difference in between the output. So first it is moving to the granddaughter, then daughter, then it's printing the parent node, and son and grandson, this part is same, right? Now if I will move this one at last and just re-execute this code, and you can see now it's moving to the granddaughter, daughter, then grandson, son, and at last it is printing the value for its parent node. All right, thanks for watching.